Hi, this is your biology teacher, Mpaiso Leslie. Our lesson for today is the effects of pH on an enzyme reaction. In the previous lesson, we looked at the effects of temperature on enzyme reactions. All right, if you haven't watched the lesson or rather the video, please follow the link in the description box below. All right. What is it that we want to achieve by the end of this lesson? We want to show that enzymes are actually sensitive to pH, and then we also want to show that an enzyme has an optimum pH. So each enzyme works best at their own pH, right? And in our experiment, we have 5 test tubes. Now, these test tubes, they have the same content, all right? Each test tube has starch plus amylase plus iodine. If you are following our lessons, we actually explained why we have starch, why we have amylase, and why we have iodine in the previous video. All right, so the reason why we have starch plus amylase, this is because amylase is an enzyme. Now this amylase is only meant to digest starch. Remember, enzymes are specific, so amylase can only digest starch. And then why do we have iodine? We have iodine to show that starch is present or not present. Now, iodine is actually yellow to brown before testing. And then when do you get a positive reaction? If starch is present, your iodine solution will change from yellow to blue. So the reason why our test tubes are blue, or rather the solution within this test tube is blue, it's to show that our test tubes actually contains starch. All right, and then when do you get a negative response? You get a negative response when, in this case now of our experiment, a negative response will be when our test tubes will not be blue anymore. That is to show that your starch, which is contained in your test tube, was digested by amylase. Hence, your iodine solution will change from blue to yellow. Okay, now how are the test tubes different? Our 5 test tubes are different in terms of pH. They are subjected at different pH levels. All right, test tube A is subjected at pH 9, which is alkaline. Test tube B is subjected at pH 7, between 7 and 8, slightly alkaline, or rather, yes, alkaline as well. And then test tube C is subjected to a pH that is between 6 and 7. And then test tube D, which is subjected at a pH that is at 6, and then E at pH 3. Okay, so now we want to find out where are we most likely to get the fastest reaction. Now you get the fastest reaction in test tube C. Let's see our results. Now our results, we are told that in test tube C, our blue color, it will disappear fast. It will change from being blue to yellow, or rather brown. This is to show that your starch, or rather the starch that we are getting in test tube C, was digested. Why was this starch digested? It was digested because we are somehow near the pH, near the optimum pH of amylase. Hence, your test tube is changing from blue to yellow. And then test tube D and B changes color next, or rather these are they will follow C. Now we are told that the changes in these 2 test tubes, they are actually slow as compared to C. So we are told that our test tube C is the first one to change color. From there, the next test tubes to change color is test tube D and B. The reason for that is because they are near the range. Okay, and then from there we have test tube A and test tube E. Now we are told that there are very, very slow changes, or rather there is no change at all that will be observed, that will be observed in this test tube. Now, because there will be no changes, we can therefore conclude that starch was not digested by amylase. The reason to why starch was not digested by amylase, it's because these test tubes, they are off the pH range. They are, your amylase, it's not subjected at an optimum pH. Like in test tube A, you can see that this is alkaline. This is alkaline. So we can therefore conclude that amylase does not work at an alkaline level, or rather at an alkaline level, or rather it cannot work when it's subjected to an acidity level. All right, so let's now interpret our results. Now, before we start interpreting our results, we are asked to remember the following. We are asked to remember that when there is color change, that is an indication that starch was digested. When your iodine solution changes from blue to yellow, that is to show that amylase digested starch. Now, because amylase digested starch, starch is no longer present in a test tube. And also another thing we should remember is that amylase has an optimum pH. This should be P and capital H. So amylase has an optimum pH of 7. Or rather, amylase works best in a slightly alkaline environment. Okay, so let's interpret our results. Now in test tube C, which is at pH 6, between 6 and 7, we are told that changes here, they are fast, and it's the first test tube to change color. The reason for that is because we are near the pH. All right, we are near its optimum pH. We are near the optimum pH of amylase. So because we are near the optimum pH of amylase, your amylase will be able to break down starch. Now, because your amylase will be able to break down starch, now your iodine solution, it will change from blue to yellow to show that starch is no longer present in the test tube. All right, and then moving on to test tube B and test tube D, we are told that changes are there, but however these changes, they are very slow as compared to C. Now, reason for that is because they are both off the optimum pH. They are off the optimum pH. Now, because they are off the optimum pH, we are told that changes will be very, very slow as compared to what you observe in C. Now, your test tube B is a bit alkaline, whereas test tube D is actually a bit acidity. All right, and then what happens now in our two remaining test tubes? In our two remaining test tubes, we are seeing that there is very, very slow, or rather there is no reaction at all. The reason why there is no reaction is because they are far the optimum pH of amylase. Now, because they are far the optimum pH of amylase, that means that your amylase will not be able to break down starch. Now, because your amylase is not able to break down starch, your iodine solution does not change color. That is to show that your starch is still present in your two test tubes. Now, because our starch is still present in our two test tubes, then your iodine remains blue. Okay, now we are also told that test tube A is way too alkaline, which is at pH 9, and then test tube E, it's way too acidity, which is subjected to pH 3. Okay, so changes in this case are mostly to be observed in test tube C. And then what happens in test tube C? Your starch will be broken down by amylase, and then your solution will change from blue to yellow to show that starch is no longer present. And then test tube B and D will follow. Reaction in test tube B and D will be very slow as compared to C. and then in test tube A and E there will be no reaction. The reason for that is because we are off the optimum pH of amylase, all right? And then because we are off, our starch will not be digested, or rather our starch will not be broken down by amylase. So test tube A and test tube E will still contain starch. Now, how do we know that it contains starch? It's because our iodine solution will remain blue. And we know that when your iodine solution is blue, that indicates that starch is present. When iodine solution changes to yellow, that is to indicate that starch is absent. Okay, so this brings us to the end of our lesson for today. So the questions, or rather the experiments that we are doing here, you mostly find them in paper 3. So I hope you are paying attention. Please comment if you have any questions, and then we'll be able to attend to you. Thank you so much for your time. Also please do not forget to subscribe. I'm way too happy. Okay, don't forget to subscribe if you like our videos, or rather if you are enjoying our lessons. And also you have to subscribe so that you can be notified when we post new videos. We don't want you to be left out. Enough of talking. Goodbye. We meet again tomorrow.